Okay, we're now going to look at the graph of cosecant of x. Now here's the graph of cosecant of x. And of course this shouldn't be very much of a surprise. Remember when we looked at sine of x and, cosine of x and secant of x, we saw that the secant of x kind of met the cosine of x at the maxima and minima points and had these asymptotes where the cosine was equal to 0. Now since the sine is just a shift of the cosine to the right by pi over 2, it's probably no surprise that the cosecant then is just a shift to the right by pi over 2 of the secant of x. So basically the things that we notice about secant of x, we're going to notice the same thing for cosecant of x, but just shifted to the right by pi over 2. So let's get rid of those two. Let's leave these two together. This is the brown one is cosecant of x, y equals cosecant of x, and then the red one is y equals sine of x. I usually think of these two as a pair together. They're reciprocal functions. So the smaller you make sine of x, the larger you make cosecant of x. Or let's put it this way. The smaller the absolute value of sine x, the closer it is to the x-axis. The larger the absolute value of cosecant of x, the further away it is from the x-axis. And of course, when you're right here at pi over 2, or 5 pi over 2, or negative 3 pi over 2, that is the odd multiples of pi over 2, we're at a minimum on the cosecant of x when we're at a maximum on the sine. And similarly at the, well, I said odd multiples of pi over 2, only some of the odd multiples of pi over 2. So we could just say pi over 2 and then shifts of that by 2 pi. So 2 pi to the right from there, another 2 pi to the right, 2 pi to the left, another 2 pi to the left. Those places. So it's pi over 2 plus multiples of 2 pi. Those are going to be the maxima of the sine, and that's going to be the minima of the cosecant, which of course is a y is 1. We get y is at negative 1 at, say, at minus pi over 2, or at 3 pi over 2, and then shifts of that by 2 pi, 7 pi over 2. So we could write that as either minus pi over 2 plus 2n pi, or 3 pi over 2 plus 2n pi for the x's, and of course y's are negative 1. Notice it's undefined anytime the x is 0, and so we get a vertical asymptote there at when sine is 0, so that's going to be when x is pi, or 2 pi, or 0. So notice it doesn't have either an x or a y-intercept. And we do have some vertical asymptotes. So the domain is all reals except for integer multiples of pi, where it has vertical asymptotes. So let's kind of summarize the properties that we see for cosecant. The domain is all reals except for multiples of pi. N pi such that n is an integer. And when you have x equals n pi such that x is n is an integer, that's a vertical asymptote. The range is from minus infinity up to negative 1, union 1 to infinity. Does not have anything between negative 1 and 1, including means it does not touch the x-axis. Nor does it touch the y-axis, because that's one of the asymptotes. The parts where y is positive, each piece is a connected concave up piece, but then we have disconnects at the asymptotes, for example here at negative pi. And then the pieces that where y is negative are concave down. But notice there are no inflection points. The only places that changes concavity are places where the function's undefined at the vertical asymptotes. It doesn't have any global extrema. It does have these relative extrema, these local minima at pi over 2 plus 2n pi, comma 1. So y is 1. That's a local minimum. Each one of those is a local minimum. Or they're minima, plural, and the maxima are where the sine is at a minimum. So let's get rid of the sine wave and just look at that. And so we have that. So what identities do we have? Well, if we rotate this 180 degrees around the origin, we get the same looking graph, and this part in the first quadrant rotates around to hit the one in the fourth quadrant here. And so we see that as an odd function. So we see that cosecant of minus x is the same as, is the opposite of cosecant of x. Cosecant of pi minus x is the same as cosecant of x, and that's 2 points, let's say, one in here and then one in here would have the same y values. Okay, and then cosecant of pi plus x, that's when you shift over by half a period, say from here to here, and they have opposite y. So cosecant of pi plus x is the opposite of cosecant of x.